Okay, we'll get this show on the road. Kia ora, haere mai. Hello and a warm welcome to today's Brown Bag Resilience Series, or BBRS for short, a webinar lunchtime talk, which is hosted by Te Whenua, Land Information New Zealand, and Te Manatū Waka, the Ministry of Transport. I'm Jeff O'Malley, Principal Advisor, Geospatial Capability Building at LINZ, and we've also got helping here is my trusty technical assistant, Dwayne Wilkins. Today's topic is about RiskScape, which is a risk modelling tool for New Zealand, and the presenter is Richard Woods, who's a Senior Natural Hazard Risk Management Specialist with GNS Science, Te Pū Au. So if you have any questions for Richard during the webinar, put them in the chat window and we'll have some time to answer at the end. And the session's also being recorded for people who couldn't make it today. So for a start though, we've got a video that we'll have a look at first about RiskScape, and Dwayne will start that, and then we'll hand over to Richard for the presentation.
Risk managers need to assess natural hazards and their impacts to make informed decisions. RiskScape is a national research program examining the impacts of hazards on society. The RiskScape modelling tool draws on decades of cutting-edge hazard research to help you to assess the losses caused by natural hazard events. This includes the impacts on people, buildings, and other infrastructure. This information can then contribute to your mitigation and planning decisions. RiskScape is designed to help you perform complex calculations simply and quickly without needing specialist modelling knowledge. RiskScape helps you to create a scenario through a series of simple steps. You can view or export your scenario results. You can use the asset, hazard and fragility data that comes with RiskScape, or you can create scenarios using your own data. Results may include the number of exposed buildings, the degree of damage and economic loss, as well as the estimated number of casualties. It can also estimate the disruption to lifelines such as electricity, road and water networks. RiskScape has been used to provide impact data for earthquake strengthening and flood mitigation cost-benefit analysis, regional risk assessments, and emergency planning and response. Working in partnership, the RiskScape team at GNS Science and NIWA are tailoring the tool for a wide range of applications in a number of countries, including for impact forecasting. To find out how RiskScape can support your work and to download RiskScape for free, visit riskscape.org.nz.
Kia ora koutou everyone, my name is Richard Woods from GNS Science, and I'm the RiskScape program leader. My equivalent, Ryan Paulock, this presentation is on behalf of him as well at NIWA. So just before, I'll just caveat that the video, so just before you go to riskscape.org.nz to download the software, we've actually mothballed the previous software, and we've been in development of the new software since 2018, and we intend to release that as open source software either mid or towards the end of this year. So you'll see if you go to the website, you'll be redirected to GNS and NIWA, and the old software is no longer available. So just to give you some context, the RiskScape research program is a core-funded program funded by GNS and NIWA to the tune of around $1 million per year from each agency, and it's been in place since about 2004. The first release of the RiskScape software was released in 2006. And then in 2017, a review of the current software was undertaken, and it was elected to stop development on that software because it had been developed in 2006. So it was developed using software principles of the time, and all of the models were hard-coded. So it was quite difficult for us to update the science and the software. And we embarked on a new software development program to develop open source software, which we could provide to all of our end users, both domestically and internationally. And they range from emergency managers to asset owners to infrastructure companies to local government. And I'll talk about some of the applications which you can use the tool for. A quite exciting development occurred in 2019, whereby the Earthquake Commission funded us to expedite a whole lot of software development and make the model fully probabilistic. So we have a stochastic modeling suite and able to model hundreds of thousands of iterations of different hazard events, and I'll talk about that functionality. But also as part of that partnership that we're forming with EQC, EQC are replacing their internal loss modeling software to model the estimates of potential earthquakes to the New Zealand residential building stock. And so RiskScape will in future produce the evidence base which is used to negotiate New Zealand's reinsurance premium for the residential EQC portfolio. So that's a bit of background in terms of the RiskScape research program itself. So what does RiskScape do? RiskScape's a direct loss modelling framework, and to model the impacts of natural hazards, we need some information about the natural hazards themselves. So we need some hazard data, and RiskScape takes in geospatial layers, so GIS layers, for any natural hazard. Now the principles that we've developed the new software under is that the engine itself, so think of RiskScape as a big calculator, it's completely decoupled from all of the data. So there's no data hard-coded. So that means that if we have the right hazard data and information about what we're trying to model, we can model any type of natural hazard, but also other hazards. So an example would be if we had data about the spread of COVID-19 through the community and within New Zealand, and we understood how it distributed itself for specific events, we could actually use the RiskScape engine to model the spread of COVID-19, for instance. Hazard data in New Zealand, typically national models are produced by the CRI, so GNS Science, in terms of seismic layers, tsunami layers, volcanic hazard layers, and NIWA produce wind layers and some flood information as well. But typically flood information is developed at the regional council level within New Zealand, and this is important for what I'm going to be talking about later on. So we need some geospatial data about our hazard. And then we need some information about what we are trying to assess the damage to. So we need some asset data or what we call exposure data. So asset data might be information about your buildings, your infrastructure network. Typically these are provided within a GIS data set as well. But people also fit into this part. So in the old version of RiskScape, we would take the information about a building, for instance, take its floor platform area, how many stories it has in it, and its use category, and then we'd attribute a proportion of people to that building. And we're looking at new innovative ways in terms of how we develop population models for New Zealand to more effectively look at the impact of natural hazards. So once we have some information about our hazard in terms of location and how intense it is across those locations, and information about our asset, and the information about the asset might be the construction type of the building, how many stories, land use, its use type, for instance, when it was built, we can use science to understand what the likely impacts might be from each of those things for that specific building at that location or for the people at that location. So GNS and NIWA, as part of the RiskScape program, we investigate if you've got, for instance, a one-story timber frame building at a location. I like to use the three little pigs as an analogy here. If you've got the big bad wolf blowing 100-kilometre gust, your brick house is going to be a lot more resilient to that wind gust than the straw house or the timber house. So these equations or algorithms just say for any particular structure or piece of infrastructure, it could be a culvert, it could be a road, a tar seal road versus a gravel road, we would expect there's a probability assigned to that of we would expect a certain amount of damage. And so then RiskScape can use that science to produce consequences. And those consequences for people may be critical injuries, right down to no injury or deaths, for instance, or we might be looking at the reinstatement cost of buildings, for instance, if people have been displaced from buildings, where they might have been displaced from. a range of outputs can be developed. And if we start to go beyond just looking at core assets, we can look at things like impacts to crops, if we understand how the hazard might impact on specific crops, and we can run different scenarios through the model to produce those losses. So to kind of visualize that, this is what a hazard layer might look like that RiskScape uses. So there we're looking at tsunami inundation depth. I think it's a Canterbury example. And so this was what the hazard layer might look like. And that hazard layer might include not only depth, but it might include the velocity of the tsunami at any location as well, maximum velocity, which we could also use to look at impacts on different types of infrastructure, for instance, like scouring around roads. We can then add the exposure layer, so we understand the spatial distribution, in this case, of the buildings that are affected by that tsunami. And then using that science, we can then ascertain for each building what the damage state might be. So those represented in green are minor damage, right up to those represented in red are washed away. And this is just an indicative example that we've developed. So as I mentioned, the RiskScape software itself is decoupled from all of the science. So the science that RiskScape uses is user-defined, and RiskScape, like any loss model or any model that you use, if you put poor data in, you get poor results out. So you really need to have good asset data to be able to get those losses. This is just represented similar to the previous slide. We need asset, hazard, and function and types, and the architecture of the new system operates under projects or pipelines. So we can set the new system up as a project with pre-configured with all of your data so that you can just swap in new data over time. Or we have a pipeline architecture, which actually means that we can model multiple assets or multiple hazards, and that allows us to do more complex hazard analysis, which I'll talk about soon. The software itself is an engine, it's the big calculator, and it has plugins. So the stochastic modeling suite to do probabilistic assessment allows us to take a Wellington fault event, for instance, and take maybe 100,000 different iterations of that event. So the event could start in Trentham and make its way south, or it could start at 5 kilometres depth, or 10 kilometres depth, or 20 kilometres depth, or it could start in the city and move north. So it helps us to understand the likely impacts and deal with the uncertainty of the events, the natural hazard events. Sorry, there's acronyms here. We'll be developing a graphical user interface, so a web-based user interface for the system. That development's anticipated to start next financial year. At the moment, it runs on command line. So if you're a user and you're wanting to use the system, you have to have a level of programming knowledge to use it. As I said, we'll be releasing the software at some point towards the end of this year. And the intention of that release as an open source product will be for research purposes initially, and we'll be working over time to develop more front-end parts of the system to make it a lot easier to use. That pipeline architecture allows us to model complex natural hazards. So cascading events, for instance, if we were to have an earthquake, a Hikurangi subduction event off the east coast of New Zealand, for instance, we'd then have a subsequent tsunami and then fire following. The new system allows us to be able to define a more complex risk profile for that event and then model different iterations of that. Most risk models internationally will model these as discrete events, so just the earthquake against the building portfolio or just the tsunami. There's a few bells and whistles. If you're a previous user of RiskScape 1, we've equipped the new system with web feature services so that we can, once we've deployed the system and have a web-based system, we can tie that into online data sets. So if a regional council is providing their flood data online and they're constantly updating that, we can set a project up in RiskScape to bring in that data in real time. So that allows us to tie it into tools like GeoNet, for instance, and look at potentially getting casualty and loss assessments in real time from the information about earthquakes that are provided by GeoNet. I've already mentioned we can do complex analysis, so looking at stochastic and probabilistic assessment to understand the uncertainty associated with events, and EQC is a user of that functionality. We have internationalized the software, so it is multilingual. We can already operate components of it. We've tested it with Te Reo, and we use it internationally in places like Indonesia and the Pacific. And we can actually use vector-based GIS data sets. So this is one of the only models in the world, or systems in the world, that does this level of loss assessment, and that we can take vector-based, so we can take things like underground stormwater networks or roading networks and accurately understand the losses associated with those distributed networks. And that's a challenge for loss models around the world, but we've developed some really good geospatial rendering techniques to do that. So that's the plan. RiskScape, the engine, is planned to be released at some point towards the end of the year as an open source product. The 5-year kind of long-term goal is that that system would be an online-based system. We'd have the RiskScape engine here with this open source functionality. We'll have a base. You can operate it if you're a more technical user on a command line interface, but eventually, ideally, in 2022, we'll have a core user interface where users can use that. Because the system is decoupled, we can have other specific user interfaces developed. So we might develop one for the emergency management sector, for instance, that's customized, or local government. We're looking at the interoperability of other tools within New Zealand. So there's a tool called Merit, which takes RiskScape outputs and takes it into socioeconomic losses. Also global tools. So there's a global reinsurance tool called Oasis, and then looking at the other functionality around infrastructure and social models. Ideally, we'd like to get to provide the best science alongside RiskScape, the RiskScape engine, that's easily accessible, because people can't use the system if they don't have access to data. So we're looking at potentially the 3 agencies developing this as a broader New Zealand risk platform over time, whereby the RiskScape software is provided, but also we'll have outputs from the National Seismic Hazard Model, or any sort of National Tsunami Hazard Model that might be developed, or any sort of National Flood Model that might be developed, such as NIWA's working on through their Endeavour bid. We would then potentially partner with agencies like LINS to develop, to link in national data sets, such as the National LINS building data set that's being developed, or work with the lifeline groups across New Zealand to provide access to some of their data potentially. We'd have the best information available there for the science that takes the information about the hazard and asset data. So we would code this up and provide it for users to use. And then potentially we could, because it's open source, we will potentially work with international partners, and we've already had significant interest from agencies like the World Bank and NASA, whereby I travelled to DC in 2017 to give some seminars at NASA and DC, because they're particularly interested in having this as open source software that can be used internationally. So that's my webinar for today. I'll just leave you with my favourite quote from a previous Prime Minister. It's an excellent quote, and tools like RiskScape, hopefully we can better understand the risk associated with these events in New Zealand, and therefore better manage that risk into the future. My email's there. Happy for you to drop me a line, and if it's weather related, I'll forward that on to Ryan Pollock at NIWA as well. So I thank you for your time today, and happy to take any questions. Thanks, Jeff.
Yep, thanks a lot, Richard. So yeah, if you've got any questions, put them in the chat window. We've got a question coming in here. Can it be used for wildfires, particularly in the complex urban-rural interface?
So short answer, yes. And this is something that in the longer term agenda, we'd like to talk to Scion about. I know that them in partnership with FENS developed some years ago the National Wildfire Threat Analysis, and I'd like to see how we could potentially come up with solutions for implementing that in RiskScape.
Okay. So next one here is, what is the best scale for its use, suburb, region, district? Yeah,
so you can basically, site-specific is not the best because you would typically, there's a lot of uncertainty associated in applying that science. So you can't particularly go in and say, for one specific earthquake, we've had that level of damage and expect that building to be damaged. So typically it works on an aggregated basis. So we promote to use the results and outputs of RiskScape more from the suburb scale up.
Okay, here's one from Charles. Can it assess risk to bridges and culverts?
Yes, absolutely. So that's what we provide information about that. typically on an aggregated basis, but it really depends on having an understanding of how each of those assets, so a culvert or a bridge, might be impacted by different intensities of hazards. So we need to understand the science associated with that. We go and capture after events across New Zealand and internationally empirical data to develop those equations to help us perform those calculations.
Next one from Andrew Craig. What about timelines of hazards, onset of flooding, etc., and their impacts? Is this linked through the probabilistic framework?
Yeah, or we can model how that hazard might change over time. So that's one thing I didn't talk about, is that you can model your particular hazard at a particular time instance and then change that layer to represent how it might look like in a future time instance, and then compare those outputs. We do a similar thing looking at intervention options for infrastructure, whereby you can model it looking on today's asset layer, and then you can change that asset layer to represent how your infrastructure might look in future to model the cost benefits of different options. And we use it in the land use planning space. We're working with Queenstown Lakes District Council at the moment on looking at future policy options for their district plan. So in 100 years' time, if we implement 4 different types of policy options, what that might look like in terms of impacting further intensification of development in existing hazard areas.
Okay, next one from Joshua. Does RiskScape include components for groundwater modelling?
We've been talking to the groundwater team at GNS about bringing in, so the groundwater components typically feed the hazard models. So if we're looking at the impacts of liquefaction, for instance, during an earthquake, groundwater is quite a sensitive factor to potentially look at the impact for underground stormwater networks, for instance, or infrastructure underground. So we utilise the outputs from groundwater models to feed into the hazards typically.
Great. Okay, we've got heaps of questions coming. Next one from David. Could you see an application regarding risk assessment for utilities, for example, power lines and gas pipelines?
Yeah, absolutely. So our intention, and I think really we need to get into the UI space to be working with some of the lifeline or infrastructure agencies on how they might use the tool. The tool was used a couple of years ago to develop a business case for Wellington Lifelines groups and look at different intervention options there. So you might want to reference some of that work in terms of how it's been used historically.
Okay, next one. Long term, are you looking towards something like a free, open, national level online hazard risk information portal?
That's exactly what I want to get to with that 5-year slide. I don't know if it's going to take 5 years, but certainly we'll have RiskScape itself web-based within the next couple of years for all users to use.
Once the user interface is available, I guess that's the graphic user interface is available, is it envisaged it will be a commercial product or free for central local government for emergency management planning purposes?
Yeah, so we're just working through the licensing associated with that at the moment. The governance group are considering that next month, but the commitment has been made that RiskScape will be open source. There will be conditions around the commercialization of it under that open source license, and those are still being worked through, but it'll be freely available for all emergency managers, lifeline providers, local government entities or users within New Zealand to use.
From Mark, do you envisage it being coupled with non-natural hazards, for example, WorkSafe's hazardous facility database?
Absolutely, where that data is freely available, we could definitely couple that in. There is obviously sensitivities around location and the attribute data associated with particular assets that need to be worked through. So I guess that's a longer discussion over time.
Tim, this one, to what extent will it be able to provide predictive risk modelling for future climate change scenarios, and how might this be used to inform climate change exposures?
Yeah, so Ryan Pollock's already done some work on that at the national level under the Deep South Challenge, I think. And if you kind of just Google Ryan's name, he did national coverage of coastal inundation and looked at how that might change through time. Certainly, we can, if the hazard data is available, we can change those hazard data sets to represent how they might look in future, so future sea level rise scenarios or more intense storms and how that might impact on flooding intensity, and we can just run that through the system quite easily.
Okay, what do we got here? What will be included in the open source package? Only the software or data as well?
Only software, yeah.
Okay. You mentioned it would be initially released on a research usage basis at the end of the year. What would be the time frame for commercial usage?
Yeah, so I'm not, as I say, I don't have the specifics on the licensing at the moment. We're just working through that. And so there will be some limitations about fully commercializing the product, I anticipate, because we don't necessarily, these sorts of models, there are international vendors which provide similar loss outputs from their models. As I mentioned, they're complete black boxes and they make millions and millions of dollars, hundreds of millions of dollars a year. New Zealand's developed our own software, so we can have it open. We can demonstrate with the best science that we have how what our risk exposure is from across the range of natural hazards, and therefore we can form an argument about how we can effectively treat that risk. So we can demonstrate how we're being proactive in that space.
This one's from Warwick. Is it proposed to make RiskScape 2 mandatory for local councils, i.e. nationally consistent approach to modelling and assessing risk?
I think that's, in terms of mandatory, I think that's probably a question for other government departments. Certainly we'll be working with agencies like NEMA, for instance, on potentially developing best practice guides for emergency management sector, or working with other ministries on looking at how RiskScape might be configured to meet the needs of other sectors within New Zealand.
From Susan, how have all councils picked up using RiskScape for their long-term plans? Do you know the reasons if not?
No, well, with this software, we haven't even got out into the open arena at the moment, but we're working with some councils across New Zealand on how we might effectively come up with good methods to do that. I've mentioned we're working with Queenstown Lakes District Council at the moment on looking at the impacts of alluvial fan debris flows and rockfall for existing urban areas. We're in discussions with a couple of the other big councils in New Zealand, which are under commercial discussions at the moment, so I can't really reveal that. I think it's dealing with natural hazard risk across a range of perils, which vary across a range of different temporal scales and spatial scales, is quite difficult for regional councils to understand how they might do that. So I think we can be more proactive in the science area to come up with decision support tools that RiskScape uses for council staff to be able to effectively come up with solutions to manage that risk.
Next one's from Charles. Are all of the vulnerability models developed specifically for New Zealand?
No, so there are vulnerability models all across the world. As you'll understand, buildings in Indonesia are quite different to buildings in New Zealand. Where possible, we can use international proxies, but the science that goes on in New Zealand is always benchmarked against similar models, similar international models, to just look at how relevant they might be. Yeah.
Okay, here's a comment, I think, from Ryan Paulick. So Ryan saying RiskScape can model impacts at feature site, for example, building scale. Then the user has the options to report impacts at this scale or aggregate and report for larger geographical areas, for example, suburbs. Yep.
Thanks, Ryan.
Tim has got one. To what extent will it be able to provide predictive risk modelling for future climate change scenarios? I think we've asked that one, have we? And how might this be used to inform climate change exposures? Got that one?
Yeah, and Ryan's got some good ideas about that too.
Okay. How about this one? Will you help us to collaborate by publishing a schema definition for required geospatial inputs?
Oh, sorry, you cut out there, Jeff. I heard schema.
Okay. All right. Can you hear me now?
Yep.
Yeah, okay. Will you help us to collaborate by publishing a schema definition for required geospatial inputs? Yeah,
so I mean, data management is extremely problematic. We have been focused on the development of the software at the moment, but of course you need certain attributes to be used in the science that assesses the impacts of those vulnerability models. I know that the World Bank have developed an international schema, and that's something that New Zealand may look to adopt, but I think if we're going to have an online system with data in it, we have to have some controls around data schemas and what attributes are associated with geospatial data sets. So we're always open to having those discussions. Yeah.
Okay, we're on 1 o'clock, but we'll keep on going for another minute or two. There's still questions coming in. Can users incorporate various vulnerability and fragility equations in RiskScape to compare loss and impact models?
Yes, absolutely. If you've got the ability to code those yourself, if they're your personal ones, absolutely.
Okay.
So the language, and just on that, the languages that are used currently to code those, we use a hybrid language called Jython, but we're also getting Java capability in there as well. So you can use Java, Jython, or Python.
Okay. What are the timelines on releasing version 2.0?
Good question. That's a question I'll put to our governance group who are meeting in March. And it's reliant on a number of things, us getting the licensing sorted and the like, but we're anticipating mid to end of this year for the first release.
Okay. The new web interface option is a great initiative. Will an installation of software, for example, the engine on a local machine, still be required to enable full web-based functionality?
In the short term, yes. In the long term, we're looking to have an online web-based system. So that's in the longer term, and I'd say we'll be pushing out more into the 2 to 3 years to have a web-based system where people could just go on and use the system.
Yeah. What technical and training supports would be available for national and international researchers?
Yeah, so part of the RiskScape program, we have an end user engagement outreach component to that, and we at the moment are focused on running workshops and upskilling people within the university curriculums, just to try and get a tranche of risk modelers through and people interested in using risk modeling. So we're working on support packages for that. At the moment, it's typically user-led, and there's documentation around installation and how the current system works.
Okay, that's the end of the question. Just a comment from Carl here, Carl Baker here at LINS. I was involved in an experiment at Canterbury University a few weeks ago. We had some really good outcomes for urban flood mapping, involved all sorts of people, local, national, utilities and lifelines. Great, thanks for that input. And we've managed 2 or 3 minutes over time, but we've got rid of all the questions. So really thank you, Richard, for your work there and for the presentation, most interesting and informative. And Richard's given his email address if you want to follow up on any other things. So please take advantage of that. And thanks everyone for your attendance, and keep an eye out for the next Brown Bag Resilience Series lunchtime webinar. So, haere rā. Bye.
Thanks everyone.